What if I told you that the most powerful weapon ever created by mankind works through the same process that powers the sun? Nuclear bombs are terrifyingly complex, yet based on surprisingly simple physics. In this video, we'll break down how nuclear bombs work, from the science behind the explosion to the two main types of bombs, and how just a few kilograms of material can level entire cities. Let's begin. Everything begins at the atomic level. Atoms are made of a nucleus, containing protons and neutrons, and a cloud of electrons orbiting around it. Nuclear bombs rely on nuclear reactions, either fission or fusion. Fission is the splitting of heavy atomic nuclei, like uranium-235 or plutonium-239. Fusion is the combining of light atomic nuclei, like hydrogen isotopes. Both reactions release massive amounts of energy, following Einstein's equation, E equals mc squared, where a tiny amount of mass is converted directly into energy. The first nuclear bombs ever made, like those dropped on Hiroshima and Nagasaki, were fission bombs. Here's how they work, step by step. First, the bomb uses enriched uranium-5 or plutonium-239, both capable of sustaining a chain reaction as fissile material. Next, to start a chain reaction, there needs to be a critical mass, a minimum amount of fissile material to sustain the explosion. Then, there are two main detonation mechanism designs. The gun-type bomb, used in Hiroshima, involves a conventional explosive firing one piece of uranium into another to create a supercritical mass. It's simple but only works with uranium. The implosion-type bomb, used in Nagasaki, uses high explosives to compress a plutonium core into a supercritical state. This is much more efficient and commonly used in modern warheads. Once critical mass is achieved, neutrons are released and bombard other nuclei, causing them to split and release more neutrons. This chain reaction escalates exponentially in a fraction of a second. The most powerful bombs today are not fission bombs, but fusion bombs, also known as thermonuclear weapons or hydrogen bombs. How it works. A hydrogen bomb uses a fission bomb as a trigger to ignite fusion reactions in hydrogen isotopes like deuterium and tritium. The fusion of these light nuclei releases even more energy than fission. Temperatures reach over 100 million degrees Celsius, hotter than the core of the sun. A nuclear explosion unleashes destruction in multiple ways. The blast wave destroys buildings over miles. Thermal radiation causes instant fires and burns. Ionizing radiation damages DNA and causes radiation sickness. An electromagnetic pulse, or EMP, disrupts electronics. And fallout, radioactive particles, can contaminate land and water for years. In Hiroshima, around 70,000 people died instantly. By the end of the year, over 140,000 had perished. As of today, 9 countries possess nuclear weapons. Thousands of warheads exist, many on hair-trigger alert. Treaties like the Non-Proliferation Treaty, NPT, and Comprehensive Nuclear Test Ban Treaty, CTBT, aim to prevent their spread and use. But tensions remain. The power of nuclear weapons continues to shape geopolitics, military strategy, and even diplomacy. Nuclear bombs are scientific marvels and terrifying reminders of humanity's destructive potential. Understanding how they work is not just about physics, it's about responsibility, because the more we know, the more we can push for a safer, more peaceful world. If you learned something new, make sure to like, subscribe, and hit the bell icon. Comment below. Should the world eliminate nuclear weapons for good?